Okay, here we go with several math note sections and little pieces to practice with them. Mostly review from Algebra 2 and a little bit from geometry that we really need to get down before this next test. So take good notes, mark things that are in boxes in your book and on these videos in your math notes as things into your math notebook as things that are really important to study and have ready to go and memorized. We're going to be doing in this video number 102, 105, 107, 108, 110, 114, 115, 117, and 118. So if we run out of time, I will chop this into two videos. So make sure if I don't get through 118 in this video that you look in for a second, a part 2 to this video. So let's get started. Fractional exponents. This is something that we have done before. This is where if you're doing a cube root, that would be the same as to the 1/3 power. This says x to the 1 over n is identical to the nth root. So if I said x to the 1/3, that could be rewritten as the cube root of x. And if you put 2 together, that's the same as having the exponent with the radical. So basically, in a nutshell, get another color here. Yeah, it's not going to let me. In a nutshell, if I say x to the 2/3 power, the numerator in the fractional exponent is the exponent, and the denominator is the root. So this can be rewritten as x to the 2nd power cube rooted, or the cube root of x squared. All right, so let's take a look and apply that here. So if I've got 64 to the 2/3 power, this is the same as 64 to the 1/3 power raised to the 2nd power, which could be rewritten as the cube root of 64 raised to the 2nd power, which is the same thing as 4 to the 2nd power, which is 16. Because 4 times 4 times 4 is 64. Okay, here's 125 to the 4/3 power. So the denominator is raised to the 1/3. It's the same as the cube root. So the cube root of 125. And then we want to take that and raise it all to the 4th. So the cube root of 125 is 5. And then we're calculating 5 to the 4th. And 5 to the 4th is 625. Okay, so give that a try with this one. Break it up. It's going to be a 4th root and a 3rd power, and then figure out what you get in the end. And on D here, this negative indicates the very first thing we do is flip over the fraction, do the reciprocal. So we're going to end up with 8 over 27, and that's all raised to the positive 2/3. It's positive now because we've already taken care of the reciprocal. So you go ahead and finish that one as well. You're going to cube root the 8 and the 27 and then square each of the results and get the final. So you work on those. Okay, moving on to the next one. All right, this is a review here of how to use the special right triangles. We need to remember 45, 45, 90 and 30, 60, 90. And here's our ratios for 45, 45, 90. These two legs are exactly the same, and then remember the hypotenuse is the leg multiplied by the square root of 2. And if we want to reverse that, we can divide by the square root of 2 to get back. And in the 30, 60, 90, it's the hypotenuse divided by 2 gives the short leg, and the short leg times the square root of 3 gives the long leg. So let's see what we get here. The square to the right has a length of n on its sides. What is the length of the diagonal? Use exact values. So the diagonal here would be n times the square root of 2, according to our little rule here. Remembering that? I hope so. Okay, for B, what is the measure of the angle labeled x? Well, that's cutting a 90-degree angle in half. If that's a square, half of 90 is 45, so x is 45 degrees. Now on to C. C, the triangle to the right is equilateral, so each of those angles is 60, correct? So the measure of angle y must be 60 degrees. And use exact values. Okay, so what is the length of the altitude? So if this is 2n, this is 2n, this is 2n, each of these is n. And the altitude, k, is going to be n times the square root of 3. If you remember this right here. Okay, get that in your notes, get it memorized, ask questions if you're stuck. Okay, law of sines. Let me adjust this real quick. There we go. This is a really great example of law of cosines. We need to get this and a good example into your notes and follow along all the steps so that you are all set with how to find that. So using the law of cosines in triangle sun, where we've got 6, 12, and 8 as the sides, solve the triangle. So the first thing we're going to do is find the value of angle u. Okay, and we're going to use the law of cosines. So this is what we're looking for here, the value of angle u. If you remember, law of cosines says c squared is equal to a squared plus b squared. It's just like the Pythagorean theorem, and then minus 2 times a times b times cosine of c. Okay, so what all of these mean is basically your A and B are your sides, and C would then be the angle between those two sides. So if I'm trying to deal with this angle here, I'm going to think of the 6 and the 8 as my A and B. And then C, side C is going to be the other side, and angle C is going to be here. Okay, so let's see how that maps out. So I'm going to think of this as C, this is A, and this is B, or reversed. Those don't really matter. And then this is going to be thought of as angle C. So 12 squared, 8 squared for my B, 6 squared minus 2 times the 6 and the 8 again, times the cosine of angle U, which we think of as angle C. So we substitute all those values. So calculate all of these, square that, we get 144. Square the 8 and the 6 and add them together and we get 100. Multiply each of these together and we get 96. And so let's subtract 100 from both sides and we've got 44 is equal to negative 96 cosine of u. Now we divide both sides by 96 and simplify. So we're by negative 96. Dividing by negative 96. And then we're left with negative 11 over 24. And since this angle here is unknown, this is where we're going to do the inverse cosine of both sides. I hope you remember doing that to be able to solve for u. So we inverse cosine a negative 11 over 24 and use the calculator and we get approximately that. Okay, so let's try another problem that applies this. Let me adjust this. Let me make it fit the page. Here we go. Okay, so two streets bordering a triangle make an angle of 74 degrees. The lengths of the two sides of the lot are 126 and 110. You want to build a fence on the third side that we're not sure about, but you only have 100 feet of fencing. Is this enough? So find the other two angles and do we have enough fencing altogether? So what we need to do is find out this distance here. This is what we want to know. So if the angle that we know needs to be angle C, let's think of this as angle C. The side across from it's going to be side C, and let's call these others A and B. So we're going to start with side C is our unknown. So C squared is equal to A squared, 110 squared, plus B squared, which is 126 squared, minus 2 times A times B times the cosine of angle C, which is 74 degrees. Okay, so here's another thing to take careful note of, the order of operations in calculating all of this. So we'll leave our C squared here as is. We need to calculate these. Okay, all of this can be put into the calculator together and calculated. Press enter and we find that that comes to 27976. And then all of this can be calculated together. And we'll leave the cosine at the end. So 2, 110. Oh, oops, that's not what I wanted to do. Actually, in this case, all of this can be typed directly into a nice calculator all at once, and you'd come up with the final result. You could do this in pieces, which is what I was about to do, but it can be even faster if we just go directly to put all of that in there, and we end up with 20335.3325. And when square rooting both sides to find the value of C, we find 142.6 when rounded to one decimal place, and that is in feet. So we do have enough fencing. Then it says to find the two other angles in the lot. So this can be done by repeating the law of cosines or using the law of sines, which would actually be a little bit easier. So I'm going to leave you as part of your homework to finish doing that. Use the law of sines and find the other two angles. That means this angle here and this angle here. And then let's go ahead and skip part C. Let's just keep going. Okay? All right. And then onto this one, let me adjust this pick a little bit so we can see the instructions. There we go. Okay, you can use the law of cosines in two of these situations. Identify those that you cannot and explain why not. Do not do any calculations. So let's take a look at A. What we need to have to be able to use the law of cosines is two sides with an angle in between them. And that's what we've got on A. So I think that one's good. We can use the law of cosines there. On B, all we have is two sides. We have no angle. Since we have no angle, we're not exactly sure. This could be any measure, so we're not able to use the law of cosines there. In part C, we're not going, let's see, we've got two angles right here and one side. So we would be able to find another angle right here, and then we could Okay, I need to back up a little bit because as I see in my textbook, there's actually a 7 here on part B. So if we have got three sides, we can use the law of cosine. So this one will work. C and D are the ones that are not going to work with the law of sines, or with the law of cosines. On C, you can use the law of sines because we have a matching angle and side, and then another angle with a missing side. So we can use the law of sines to find that one, but law of cosines would make a two possible answers in this case. And on D, the angles are given, but there's no determined side, so you can't use the law of sines or cosines in this case. Okay, going to move on to another video.